Server virtualization has evolved over a number of years from being a nice-to-have technology to a mature business differentiator. By virtualizing their infrastructure, organizations now have the ability to control and cut costs while improving the scalability, flexibility, and reach of their IT systems. However, with these advances comes the realization that virtualization by itself does not allow organizations to build or take advantage of cloud services, which is assuming an ever-growing role in the execution of business tasks. Virtualization alone is no longer enough to meet the demands of modern IT, to meet customer requirements, all while reducing cost and complexity. Now organizations need to look at abstracting not only their compute, but also their storage and networking, to provide a flexible and agile IT infrastructure as the base for their push into cloud services. In this example, let's look into the solutions you can use to ensure the successful provisioning of virtualized infrastructure for your organization. Firstly, why do you want to deploy just a virtualized infrastructure? Ultimately, you want to deploy an infrastructure that would enable IT to scale compute, storage, management, and network independently. This allows you to lower the infrastructure cost and increase operational efficiencies, automate repeatable tasks to focus on strategic projects, benefit from a high level of cross-platform interoperability, and build and deploy modern, self-service, and highly available applications that can span data centers. Let's take a look at how Hyper-V as the core virtualization platform, along with System Center 2012 R2 as the cloud management system, can not only help IT admins construct an infrastructure that can support your key workloads in a virtualized environment today, but also provides vast resources for future growth. Firstly, we're going to take a look at storage. Hyper-V, along with System Center 2012 R2 Virtual Machine Manager, integrate fully with existing SAN-based investments. Hyper-V can utilize SAN storage for virtual machines, and also through features like offloaded data transfer, can offload certain SAN-related activities, such as a storage migration, to the SAN itself for accelerated performance. With VMM 2012 R2, the IT admin can integrate deeply with the SAN via the SMIS and SMP providers, enabling the IT admin to perform activities such as storage discovery, classification, provisioning, allocation, and decommissioning, all from within VMM. This could be for iSCSI storage or fiber channel storage, and with the latter, VMM can even integrate with the fiber channel fabric switches themselves. We're not going to take that approach, however. In this example, we'll be utilizing lower cost, high volume hardware such as JBOD storage, which in this case contains a mixture of spinning hard disk drives and solid state drives. These JBODs are attached via industry standard SAS connections to Windows Server 2012 R2 file servers. It's these file servers that provide the intelligence. They enable an administrator to aggregate the individual raw disks presented through the JBOD into storage pools. These storage pools can then be sliced into storage spaces, in the same way a LUN could be carved on a traditional SAN. These spaces support advanced features such as thin provisioning, mirroring, trim and unmap, deduplication, and with Windows Server 2012 R2, storage tiering. Tiering allows the system to move and optionally pin hot data in the superfast SSD tiers while utilizing larger capacity HDD tiers for handling the colder data. It's these spaces that will hold our Hyper-V virtual machines along with other important data. As I said, at the compute layer of this particular storage stack is the Windows Server file server, and we can utilize the failover clustering capability to connect multiple Windows Server file servers together to form a scale-out file server. The scale-out file server is designed to provide access to resilient file shares that are continuously available for file-based server application storage. Scale-out file shares provide the ability to share the same folder from multiple nodes of the same cluster. For instance, if you had a 4-node file server cluster that is using SMB scale-out, a Hyper-V host can access file shares from any of the 4 nodes. The Hyper-V hosts connect to the file shares over the network utilizing the SMB3 protocol, which has been optimized to provide local-like performance, yet at the same time, simplified administration and provisioning. In addition, features like SMB multi-channel, which takes advantage of multiple NICs in your file servers, and SMB Direct, an integration with NICs that have an RDMA capability, provide both increased resilience and performance for connectivity to the file servers. When it comes to provisioning, not only can VMM provision traditional storage to your Hyper-V hosts, as we learned earlier, but VMM can also deploy and configure our scale-out file server. Once you've physically connected your chosen servers to your storage, VMM can do the rest. Whether the chosen servers already have a Windows Server 2012 R2 image present, or whether they are completely blank, VMM can deploy and configure the servers, including configuration of the scale-out file server. So within no time at all, you can go from nothing to resilient, high-performing storage, which can then be quickly allocated to your Hyper-V hosts. Now let's take a look at compute. Here we have VMM. Just like VMM can deploy file servers and combine them into powerful scale-out file servers, it can do the same for Hyper-V hosts. In VMM's library, the IT admin defines a physical computer profile and imports any relevant drivers for the target system. VMM then communicates out of band with a target physical system and performs a deep discovery to understand just what's under the hood of that physical system. It then deploys a Hyper-V enabled image to that system, taking care of network and storage configuration along the way. Once deployment is finished, VMM can be used to combine Hyper-V hosts into clusters to provide resilience for your VMs. In Windows Server 2012 R2, we support clusters of up to 64 physical nodes and up to 8,000 VMs per cluster, which is pretty scalable. Each individual host can scale up to 320 logical processors, 4 terabytes of RAM, and support up to 1,024 VMs. From a VM perspective, Hyper-V provides immense scalability, supporting up to 64 virtual processors and 1 terabyte of RAM per VM, meaning you can consolidate the biggest workloads on the virtualization platform. For those VMs that have significant data storage requirements, each virtual hard disk can be up to 64 terabytes in size, with each VM supporting up to 256 of these, providing a total of 16 petabytes of storage per VM. With Windows Server 2012 R2, these virtual hard disks can be resized on the fly, either growing or shrinking without downtime. And in addition, with 2012 R2, the new shared VHDX feature enables these virtual hard disks to be attached to multiple VMs simultaneously, unlocking new guest clustering scenarios for an extra level of application resilience within VMs. So we now have our virtual machines, but what about moving them around? Well, we still continue to support live migration for virtual machines between clustered and non-clustered environments, enabling you to move your VMs from host to host with zero downtime. And in R2, we've evolved that even further. The first example is live migration with compression. Live migration with compression is the new default option for live migration in 2012 R2 and essentially utilizes the spare CPU cycles on your Hyper-V hosts to compress any memory before sending it over the network and then decompress the memory on the destination side. This means less data is sent across the network and a faster migration time. In our internal testing, we've seen anywhere between a 2x and 6x performance improvement with compression, and it's recommended on live migration networks of 10 gigabit or less. The second example is live migration over SMB. With live migration over SMB, the memory contents of the VM are copied over the network using SMB 3.0 as a transport. This means you can take advantage of some of the key SMB features to accelerate the process. SMB multi-channel for aggregating the bandwidth of the live migration networks, and SMB Direct for integrating with the RDMA capable hardware with network speeds of 40, 56 or even 100 gigabits per second, which will be available in the near future. If you've got live migration network speeds of over 10 gig Ethernet, we recommend to utilize the live migration over SMB option, as this will provide you with the fastest live migration performance in the industry. And finally, we think about networking. When it comes to networking with Hyper-V, network virtualization will change the way we define, build, and deploy networks within our virtualized infrastructure. Hyper-V network virtualization abstracts the physical network from VM networks in a similar way to how server virtualization abstracts the physical host from virtual machines. Network virtualization removes the constraints of VLAN and hierarchical IP address assignment from virtual machine provisioning. This flexibility makes it easy for customers to move to IaaS clouds and efficient for hosters and data center admins to manage their infrastructure, while maintaining the necessary multi-tenant isolation, security requirements, and supporting overlapping virtual machine IP addresses. For example, here we have a number of Hyper-V hosts together on a routable network, and these are managed by VMM. On top of these hosts, we've deployed a number of virtual machines. These VMs have been deployed onto different VM networks. Firstly, a red network, and secondly, a blue network. These have been created, deployed, and are managed by VMM. You'll notice the IP addresses of these virtual machines: 10.10.10.1, and in the red network, 10.10.10.1 for this first virtual machine. These are completely identical, yet they're running on the same physical fabric, but they don't conflict because network virtualization is isolating them from one another. The IP address that's provided to a guest virtual machine is known as a customer address. Customer addresses are unique IP addresses assigned to each VM that will be participating in a virtualized network. I like to think of the CA address as a container address because they are IP addresses assigned to each VM container for use by the guest operating system running inside that VM. Using NVGRE, multiple CAs for VMs running on the Hyper-V host can be tunneled using a single provider address. This is an IP address associated with the physical host, routable on the physical network. To manage and maintain the relationships between PA and CA, and ultimately enable VMs to float across the flat fabric, VMM maintains the centralized network virtualization policy table. The additional flexibility in virtual machine placement makes it possible to move workloads anywhere in the data center without changing the virtual machines or reconfiguring the networks. For example, Hyper-V network virtualization enables cross-subnet live migration, so that a virtual machine can live migrate anywhere in the data center without a service disruption. Previously, live migration was limited to the same subnet, restricting where virtual machines could be located. Cross-subnet live migration allows administrators to consolidate workloads based on dynamic resource requirements, energy efficiency, and can also accommodate infrastructure maintenance without disrupting customer workload uptime. But how do these VMs that are contained within these VM networks communicate out of their VM network to the rest of the infrastructure or to the internet? How do systems which don't understand network virtualization communicate with a VM that's within a VM network? That's where the gateway comes in. Windows Server 2012 R2 provides an in-box, multi-tenant, site-to-site VPN gateway to solve that specific problem, providing scalable, resilient routing and translation between the physical and virtual addresses, allowing VMs and physical systems to communicate seamlessly. In this short video, we've looked at how Windows Server 2012 R2 Hyper-V, along with System Center 2012 R2, provide a powerful combination to enable you to provision your virtualized infrastructure. They enable you to go beyond just creating virtual machines, instead providing the ability to virtualize compute, storage, and networking into a scalable, comprehensively managed set of resources that can meet the needs of your key workloads today and into the future. Try it out today.